Welcome back. Today we have yet another K7000. This time it's a 19-inch 7000, and it's in pretty rough shape. I don't want to say it's in terrible shape, but it's somewhat rough. So we'll get to that here shortly. But this was sent in for repair, and the person that owns this says they picked up the chassis just like this. Has a small crack on one corner that should not matter. As a matter of fact, it has one broken piece over here. And this side has a little bit of damage as well. This has some shipping casualty damage as well. The green drive pot is broken from shipping, and I think this little missing corner also took a whack because this was shipped in a box without any wrap whatsoever. They just took this and put it in a box and sent it up here. Now, I don't hold the owner of this responsible because he asked someone else to send this for him, and they shipped it like that. But regardless, it seems to be relatively intact from shipping, except the only real casualty is this broken green drive pot and the little chip off the corner. But he also says here that he received it like this. He replaced a few caps and R104, which is this one here, which we'll test that shortly. And detected two cracked solder joints, nothing major. It had a broken brightness pot, but actually the brightness pot is missing completely from the board. The chassis won't turn on at all. So the current situation is it won't turn on at all. It's missing a brightness pot. R104 is suspect, and it's not really even soldered in properly. And we have the broken corner here. Again, the broken corner is all part of the ground plane, so that's not a problem at all. And over here, it's not really a big deal either, so that's not a problem. If we zoom in here and just take a look at some things, it does appear to be complete, however, pretty darn dirty and crusty. But overall, not too bad. Our 101's loose, so that's par for the course. The 19-inch doesn't use R96. A lot of them don't use R96, so it's missing, so no big deal there if you notice that. So R89 is completely loose. R101 is completely loose. R104 is also loose. And the missing brightness pot, the broken green drive pot, the rest of them survived intact. We don't want these transistors to touch each other, so we'll bend that out of the way. And that's a cracked joint right there on the next socket. The rest of them seem okay. We'll have to reflow that. The rest of this seems all right. And if we look at this here, this cap's been changed and it's secure. This one's been changed, but it's all wobbly. This one here has been changed, but it's not sitting flat on the board for some reason. So has this one. So has that one. So some caps have been changed, but it looks like these two in here have also been replaced. But the smaller ones, the bipolar caps, these here, that one, all these here, those are all factory. So a partial cap kit, but we'll put the good ones in there and redo the whole thing anyway. But otherwise, other than the loose components, I don't see anything immediately faulty here. It does have the original white knob flyback, and it does have a crack across the case here, which is, again, very par for the course on the white knob flybacks. I'm not going to replace it. If we test this out and it's not leaking any high voltage out of the crack, I'm not going to change it. If it operates and works perfectly with no problems, it's not leaking high voltage, I'm not going to change it, because this could last 10 more years, where I could put a reproduction in here and it might last 10 more days. So if this is working with no issues, not leaking high voltage, we're going to keep this in here, and I'll show you how to test for high voltage leakage. I want to say safely, but without, if you have a cracked flyback like this that might be suspect when it comes to leaking high voltage, before you try and use your fingers to adjust the knobs, where you can grab a screwdriver here with a metal end and clip on an alligator clip, and the other end you clip to the frame, and you kind of hover it around here, and if you don't get any high voltage jumping out to the screwdriver, then the flyback is not leaking, and you can use your fingers to adjust stuff if you want to. That's what we'll do if I remember to do that. But okay, now let's flip this around and check this out. And already I can tell you from looking at it earlier that this cap is So that trace got lifted, but we can repair this a lot better than that. It's no big deal, but it is in the circuit. And I do want to say that there, before I show it to you, there's some real butchery going on with some of these solder joints. And it's the, I can tell you exactly the reason. It's because the soldering iron that was used to do this was not hot enough. I have a sneaky suspicion, I suspect, that this was a case of someone trying to reflow these joints and do this cap kit, partial cap kit, and rework on this, and they were using like a 15-watt Radio Shack soldering iron. But it gets to like 320 Fahrenheit, and that's about as hot as it gets, which is about 500 or 450 degrees too cold. But then we have this issue here off of one of the legs of the HOT that they've put a little jumper on, but the real butchery are the yoke header pins here. This is crazy. This is a direct result of somebody using a soldering iron that does not get anywhere near hot enough. And yeah, this is just really bad. It's just a cold blobs of solder on here. So we're going to have to redo that. But this right here will have nothing to do with it not powering on. So yeah, we got this here. We've got this here. We have this right there. That's not any good right there. The rest of this stuff, I don't know. It's going to be interesting to see what we can find. Now R104 here. Actually, the joints are okay, but we'll have to figure out something other than that, because that's not, I don't think that's quite right. Well, either way, an R89 is also loose. Well, that's why it won't turn on. R89 is broken off the, yeah, so R89 is out of circuit. With R89 out of circuit, you won't have any power at all. So right there's bad. And, oh geez, look at this. Here's the other joint. It's not a spike lead joint, it's just a regular solder joint. But you can see here, if I pull on the resistor, so R89 is completely out of circuit on both ends. We got a broken pad and a completely broken joint there. It's just coming right out. So we'll have to fix that. As a matter of fact, I'm just going to take this out real quick. Again, par for the course on all this stuff. Yeah, look at that. So here's going to be a good example of the pad's not lifted. Looking at this, the pad's not lifted. What the problem is that it's just so completely terribly oxidized from heat that it looks like the pad's missing. So here's the resistor we pulled out. It looks like the pad's missing right there, but it's not. It's just completely, totally oxidized. This is a prime example of why it's important to not just reflow joints. You need to, technically, by the letter of the law, reflow means to remove the existing solder and flow new solder. That's as in reflow. If you were to simply try to add fresh solder to this joint, it would just do what I just did and fall right off. And you have to fix the joint, or the pad, I should say. I should say a lot. Where the heck are here? Why the hell are they over there? All right. So let's fix this by grabbing one of these fiberglass pins that are used to scratch. It's a spot sanding pin with actual real fiberglass and not that stuff you get off of Amazon, the cheap stuff. And this came off Amazon, but the cheap ones that aren't actual fiberglass. This is real fiberglass. So you can see just how bad an oxidized, this joint should be shiny and it's brown. So the resistor was popping off of the joint because it wasn't even soldered down because of how oxidized it was. So I'll link these down below. Get one of these for yourself, and you'll see here if we just kind of go around with this fiberglass brush here. Look at that. Oh, look at that. That looks so good now. So it's important to do this. Not just with R89, but R101, R89, and R104. Not necessarily 104. There's not much heat generated through this, but R89, both joints on R89. This joint here and that one, and then both joints on R101, that one and that one. So let's start by inspecting the other R89 by getting rid of the solder here. And after going through here with the braid, it's still shiny, so that one's not oxidized. That one's good. R101, let's go ahead and do the same thing with R101. And yep, that one's oxidized. Case in point. Oh my lord, look at that one. Holy crap. Let's get R101 out of here now. There we go. And it's not wanting to come out because there's solder on there still. And there we go. Man, this one's in bad shape. Look at this here. That one is black. And that one also is, well, brown like that one was. But with the quick flick of the wrist and our fiberglass pen, I'm going to take away all that there so we can make a nice bridge. And this one over here, now this pad likes to lift, so I wouldn't recommend going in a circle. I would just start here and kind of sweep to the side. And there we go. So those are going to be some very nice joints when we get this stuff back together. And also part of the problem you deal with, I'm going off camera here to brush off the fiberglass bristles into my trash can, because again, these are real fiberglass remnants that you don't want to get in your skin or anything. So that's looking good. So one of the other things you have to do is realize that your legs of your components are also going to be partially oxidized. So let's get the solder off of these. And actually they're not bad. These aren't too bad. Yeah, so I'm okay putting that back in. Now, R101 here is a different story. This should be shiny, and the whole leg is dull. And the whole leg is dull except for that little tip there. So we're going to go through here and kind of clean off some of this stuff. Both sides. And that's better. That's better. Yeah, that's good. This side over here, make sure you get both sides. Nice and shiny there. And this side, from dull to good. Now I need to brush all this off. We'll do it this way. Okay. Now, we can test these two components, make sure they read what they're supposed to. R89 should be 3.9 K, and we get open. These are good, 0.1. And we get open. Wait a minute. That's not even the right freaking resistor. That's R104. That's R104. Oh, that's the one I had off to the side. Here's R89. 3.9K. Yes, 3.937. Well, now I know why they replaced this one, because it's open. So R104 indeed is open. But that also explains why the legs weren't oxidized. Now if we get the actual R89, they're not bad either. That one's got exposed copper, looks like. The nickel plating has gone off of it. This one here though, nice. Nice, okay. Now we're sitting good for our R89. R101 should be about 6.5K out of circuit here, and about 5K in circuit when the HOT is within specs. So yeah, 6.5, perfect. All right, so we have good components there. We can reinstall them. And now you'll get to see what this stuff looks like when it's done properly. So R101 going back in. Nice. That's good. R89. Make sure I don't put R104 back in there. Okay, that's good. I'll stay there. And we're gonna have to tack this in place. I'm gonna turn my fan on here, get loud a little bit. And we're just gonna add a little solder to this and just tack that in like so. All right. So now let's zoom in and take a look at what this should look like when it's good. Sometimes you scrape away a little bit and that'll suffice. R101 here. We're going to push a little bit so a little bit more of the leg is exposed. Now we'll come over here and build a nice bridge. That looks good there. Different angle. There you see. Looks great there. Now let's hit over here. And again, I'm doing the same thing. Add some solder and lift up on the, or push down I should say, on the resistors so a little bit more of the leg is exposed. And soldered to the joint. Now we can fill the rest of this. Scrape a little away. Push down. And then that's sitting as far down as it can go. And I think that'll work. Ah, nope, hang on. Well, yeah, it's good from my point of view here, but I think that should work. So, well, there you go. It looks a little bit different in the camera, but I think that should work. So there you have it. There are those joints redone. And I think it's time to go through and fix all the rest of this stuff. Nothing else really looks that bad except for, I'll go through with the meter and check everything, but I want to fix this real quick. Okay. This is just crazy. I don't even know what this is here. Get rid of some of this so we don't use it. Oh, well, what in the world? Well, we'll just use the braider. Why is there... Why are there wiring? There's wires in there. Why is there wiring in there? What in tarnation? What the? That's a first for me. Huh. Well, that is interesting. And there's supposed to be wires over here. These run off to the vertical section. Not in the pins, but right here and right here, these two. But wow. Is there wire in these two? There is. What in the world? Huh. Well, that is just insane. Somebody help me understand what the purpose of that is. Okay. And what I'm going to do here is do that, bridge to that other joint there. And then we have, oh, D18 has a bad solder joint. Look at that. I tried to reflow it and all the solder's gone. Let's see what that did there. That's a sign of a faulty solder pad. And yeah, no good. So we're going to go ahead and just kind of bristle that away. That's better. Now let's push D18 back down and see if we can work a little magic on this. Nice, okay. Now we'll bridge all that. Okay, that's a lot better. Let's make sure D18. That's a hot pin, crap. Oh, I just touched that pin. That's, oh man. Let's use the screwdriver here. Holy crap, that was hot. Okay. Some like it hot and some sweat when the soldering iron is on. I'm going to push on this D18 while I heat this joint up. Okay, there we go. I know you couldn't see it, but alright. So that is out of focus. There we go. Okay. So now I'm going to go through here and do kind of the same thing for some of the rest of these. And yes, the other leg of D18 lifted up. I see that, but we'll fix it. Okay. Holy crap. All that solder came right off that joint. Both sides of D18 completely gone. But that's better. This will be a great video explanation and showcase for how to check these joints and reflow them and do all this rework stuff. So there we go. Again, that wasn't a lifted pad like I thought it was. That was actually the joint coming apart. So let's clean this. I could do this later, but I'm going to do it now. And again, I use denatured alcohol as opposed to isopropyl because it cleans a bit better and easier to use. I mean, not that isopropyl is difficult to use, but I just like to use denatured. And my experience is it gets cleaner and easier to do this stuff. So, all right, that's good enough for now. Let's see if we can figure out what we're going to do about this here and why it's like that. Let's remove this because we don't need it. Some like it hot and some sweat when the soldering iron's on. Boom, 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 boom. I don't know what's going on here. Oh, the pad's lifted. That's what's going on. Well, again, that's no big deal. We can resolve that problem. There's way too much solder on here. Let's get rid of some of this. Nope. This one's all messed up too. I got a feeling that every damn solder joint on here is going to be bad. Maybe that's not bad. I don't know. We'll test it here. Nah, that's probably okay, but this one definitely is no good. So back to the fiberglass pin for the rescue, and we'll just eat this trace away. Or I'm sorry, the solder mask, not the trace. Solder mask off the trace. Get our bristles brushed off into the trash can. And before I bother soldering that on, I guess I probably should have tested this HOT first. So let's do just that. And so you can see here with me. Alright. Diode mode, we should get a 0.45 voltage drop or so. Negative lead on collector, and then positive to, I believe, the base and the emitter. Okay, HOT is fine. So let's solder this in here. There we go. Not trying to win any awards, but I think that'll work. So, all right, next, let's fix this. And it's going to be the same deal. We'll just eat the solder mask away and cut this. And I'm going to replace this cap anyway, but let's just go ahead and do this for now. Nice. So there we have that. So I think that's all the repairs that we are going to need to do, but before we go too much further, let's go through and do some continuity tests on these other caps that were replaced. Because we know on the previous video we had an issue where this cap had a broken pad that was causing partial collapse, because the negative lead runs through this ribbon cable, which goes right down here to R80, which is responsible for determining the vertical size limit. So let's go through here and test some of these. So okay, that's good. 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 Man. They also changed the R105 thermistor, it looks like. Oh, this isn't even soldered in. I knew that felt loose. Look at this. Another case of not having an iron that's hot enough. This is moving, and it's not soldered in. The joint seems okay, but if you look here, see that? It's not actually soldered in. Neither is the other one. The other leg here. Oh, right there, this one. See that? Neither one of these are. I bet I could just pull it right out. Yep. Well, so I'll have to fix that. Jeez. Casualty of not having an iron that's hot enough. You end up with things like this. So I don't think these joints don't really ever go bad. They don't really ever go bad because there's not enough heat through these like there is for R89 and R101, but you still need to make sure that they're good. Yep, that one's fine. And that one's fine. So do I have another R104 somewhere that I can use? Because I don't trust this one. I'm not going to move the camera, but I'll test it here. Go to ohms mode, and we get 15.7 ohms. This is a 5 watt. The factory one is also a 5 watt, but I don't know. I mean, could we use this? Probably. Let's see if I actually have one before we go too far. Lots of crap in the way that I don't need right now. These are R103s. I have what appears to be, I have one, but I don't know if it's R89 or if it's R104. So let's test it here. And it is an R89. So I don't have an R104. Maybe, I mean, I do have an R104 on a donor board here. So let's get this one out. It's kind of all twisted, but I'll keep this one, and I'll give this other good one, I'm assuming it's going to be good, to this owner of this thing. Yeah, the legs are all twisted here. Let's see if I can bend these back somewhat straight. You got me all twisted up in the game. That's an obscure movie reference that I can almost guarantee nobody is gonna figure out where that came from. But if you do, hey, congrats and kudos, you win 5 internet cool points. Let's see, what does it read? It reads 15.6. Let's put this in here. So yeah, this would not have powered up at all with R89 out of circuit from bad solder joints, R101 out of circuit from bad solder joints, R104 out of circuit from bad solder joints. Yikes! R104, the original one was open, but I want to also check our rectifier diodes, because with R104 being open, I'm wondering if this got hooked up to a non-isolation transformer. And we'll go ahead and resolder in R105, which is our degauss thermistor, or degauss thermistor, however you want to refer to it. Okay, let's go back and check all of our reworked joints again. Good, good. What in the world is this? We checked those already. We have no brightness pot. We'll have to put one of those in. I checked this already. We just checked that one. Anything else that I should hit? Looks like this joint here is broken from our neckboard interconnect. That looks like it's bad. I know that wasn't it, but it caught my eye, so I had to. And yes, I just bridged those two, but this is a nightmare. Man, if we get this one working, it'll be a miracle. Those ones look fine. What about these over here? Make sure we check it on both directions here. And we'll check our flyback pins. Okay. Everything else looks fine. So, okay, I think that'll work. So now I have to go through here and check all of our components. And then we'll do our light bulb test. So, yeah, we'll have to go. I'm going to go through and do a full cap kit off camera, and we'll come back, probably do a final test after that. But, I mean, we could probably fire it up with the caps that are in here just to see what it does if there's an issue, and then see if my rework can fix it. But we'll start off here. Before we do our light bulb test, let's check our fuse. It's always a good idea to check it out of circuit, because you could be reading through something on the board where the fuse could be blown, but it reads through something on the board and gives you a false positive. Like I think the G07 or the K4900 can read. If you do this in the K4900, you'll get, even with a blown fuse, you'll still get continuity sometimes. So it depends on the fault. So I always check it out of circuit. Checks good. Okay, so let's go to R103. We should get 2.7 ohms, which you can't see. 2.7, perfect. Diode mode, D19, D20, D21, D22, D24, D23. Good, so those are good. R104 should be 15 ohms, and we know it is 15.3. R101 should be about 4.7 in circuit. We know it ran 6.5 out of circuit, and we get 4.5, 6, 7, so that's good. R89 should be 3.9K. 3.9. There's no R96. R97, I think, is what that one is. Yeah, it should be 270 ohms. 271, that's good. Okay, we'll check D18. Make sure it's not shorted. That would be bad if it is. D18 checks good. Let's check and make sure our C38 width cap is not shorted. That's these two pads here. And it is not shorted. Okay. We checked the HOT already, so the last thing to really check in the power circuit, HOT is not in the power circuit, but we checked it anyway. So HOT tests okay. Let's check our voltage regulator, and again, on the wide fat one, it's pins 1 and 4. On the tall skinny one, it's pins 3 and 4. But you can also simply go to the B+ resistor, and the solder joints look good on that. And we should get about a 180, I think. Let's see here. What is it? No, 220. I never remember. Okay, 200, 193. But if you got this reading across the resistor, then your voltage regulator is shorted. But we don't. We have 193 ohms or so. So our regulator should be good. So with all that done and reworked and inspected, I'm not worried about the brightness pot or fixing this pot quite yet. Let's go ahead and remove the collector of the HOT. If you're not comfortable doing the light bulb test by removing or isolating the collector leg of the HOT, then you can just remove the HOT completely from the circuit by removing it from the board, and then you don't have to worry about accidentally firing up the horizontal output. So by removing the collector leg of the HOT from the circuit, we can prevent the horizontal circuit from powering up, and that will allow us to do our light bulb test without risk of firing up the flyback and the high voltage on the bench. So we don't want that to happen. For some reason, some of these joints have a whole crap load of solder on them. All right, so we'll go to continuity mode, and we'll see here. So here's the pad, and now here's the leg. Nothing. Leg is nothing. I don't know if, sorry, I'm zoomed out kind of far here. The leg is nothing. Here's the pad. Leg is isolated. So Now we can fire up our light bulb test and check our power supply and make sure our B plus is 123 on the 19-inch. How you can spot this immediately, if 19-inch uses the little small resistor and the 25-inch uses the much larger resistor. So right away you can spot these and say, okay, this is 19, larger one's 25. Easiest way to identify right off the bat. So let's grab our light bulb here, hook onto the ground, hook onto the blue wire, which is the regulated side. Regulated output is the blue wire. And we're hoping for somewhere around 123 volts. Anything less would be uncivilized. And we don't have a connector, so we're going to have to grab some alligator clips here. And some of the wires have been cut off on this here, but I'm telling you. I'll tell you what, boy. And let's clip this in here. Dang it, Dale. Boys, those are the boys that were whacking in my tool shed. Okay, now let's grab this and see if we can clip into that. Volts DC. Okay, rather precarious, but let's see what happens. 1, 2, 3. There we go. 122.2, 122.3, and that's fine because the 60-watt incandescent bulb is a pretty good analog to the load on the system with the picture tube, but we'll be much closer to 123 with the actual picture tube. But 122.4 is fine for me. Our power supply section repaired. So I had no doubts, but you never know. With that complete, we can move on to the rest of the testing on this. So I think what we'll do is I'll solder that HOT back in first, otherwise I'll forget. I'll hook this up and turn it on, it won't work. I'm like, what's going on? Oh yeah, I forgot to solder in the HOT collector leg. And the load, the light bulb being connected, drains any capacitance on the circuit. So as long as you power it off and then unhook the light bulb after you power it off, the light bulb will drain any of the high voltage or anything left over inside the filter caps. Nothing to worry about there. You may look at this and think that it's bulging, but it's not. It's just this little plastic cover here. See, I can push it back down, so the filter cap is fine. I can. The only time you ever change, the only time you ever really need to change a filter cap is if you have like a AC ripple or a wave where the image is like doing a hula dance or something. Otherwise, the filter caps, they're pretty robust. Not really worry about those too much. So I think what I want to do is all of the joints that needed fixed have been fixed. So I think in the interest of science, let's go ahead and fire it up exactly as it is and see what kind of problems we have, if any. And if it works perfectly fine, then I'll go ahead and just do the cap kit, the reflow, the cleanup, and then we'll show it off and test it one last time. But we do need to replace the brightness pot. Actually, we don't really need to. It'll work without it, but we'll put a new one in anyway. This has been one of the most brutal three trifecta resistors all be messed up like that I've had come across the bench in a while. And let's go ahead and pull this drive pot out of here. Again, it'll work without this drive pot, but I want to be able to adjust some stuff and verify all of our colors are good and whatnot. So yeah, there's the individual pieces here. I don't even know if you can see. There you go. So far we got one broken pot, an open R104, a missing brightness pot, and a bunch of bad solder joints. So let's grab our brightness pot. Contrast is maxed out for some reason. V holds middle, V size. Let's put all of the pots in the middle. H hole is maxed out too for some reason. That wouldn't be good. each position in the middle. Let's see if I can find a brightness pot. I have a box of stuff here. The brightness pot, I'm not sure. Actually, the brightness pot is, why don't I have this out to where I can read it? If I was a smart man, I'd know what love is. Brightness is 2K. So let's find a 2K where we don't have to rob it from a complete kit here. Come on, you lily-livered galoot. Why is everything difficult? If someone could figure out the reason as to why everything is always difficult, that they'd make a lot of money. Because for some reason, I don't know how to figure that out. All right, do I have a 2K in here? Polo pegs. These are all polo parts. Okay, 100K, 5K, 10K, 220K. These are all pots for the polo remote board. And yeah, I don't have a 2K in here. I'm going to cut away and try and find a 2K pot without having to steal one from a dedicated prefab kit like this, and see if I can find one. So let me do that, and when I find one, I'll come back and we'll have it ready to put in. Alright, I had a whole other bag of pots here that I forgot that was in there, and I have a bunch of 2Ks here. So let's grab one of these vertical mount ones like this. That should fit right in place, and that will solve our problem. Okie dokie. And just like so, it fits right in there with the greatest of ease. And let's solder it in place. And we'll set it to the center position. Make sure it's sitting flat. And let's put it in the middle position. Booyah. Alright. Now, the drive pot here, I completely forgot about. Now I gotta find another one. It's either 2K or 200 ohms. I need to see what the other ones read, because one of the pots is 2K, the other pot is 200. And I don't remember offhand which one is which. Let's see if this one says it. Okay, 200 ohms. So the drives are 200 ohm, which I have plenty of those too, which we just saw. Everything's perfectly normal. 200. I'll grab another one just like that. Wait, this is 500. You Dr. Dingle Nut. Here's the 200. Right there. That wouldn't have been disastrous, but wouldn't have quite worked out. 200. So yeah, we had a missing pot, a broken pot, a bad R104, and how do I have two here? Did I not put... and a bunch of bad solder joints. Now, gosh dang it, did it fall out of the bag? Why do I have two here? Did I take out two? let's just grab the meter and go to ohms. 200. And, well, it's 175, but... Okay, yeah, they're both... Must have taken 2 out by mistake. I don't know. The lights are on, but no one's home. Your will is not your own. Your heart sweats. Your teeth grind. A tater tot is all you need. The wrong lyrics there. Sometimes I try to think of the words to a particular song, and the lyrics from a Weird Al song creep in. Addicted to Spuds creeped into my mind there. So here's that bad solder joint on this. I don't know if we can get too close on that, but right there, it's cracked around there. So we'll hit that real quick. Almost forgot that. First thing I pointed out and almost forgot. The rest of this is good enough for now, which is another Weird Al song. A deep cut. Alright, so I think I want to try this now. We are ready. So I will grab a tube, get this hooked up, and we shall see what we get. Alright, so again here we're on with the iPhone, so I'm sorry if it sounds a bit different, but again it handles the refresh rate a little bit better than this overhead camera there. So everything's connected. We have our anode, neck, yoke is hooked up. We have our DAG ground, power, video, and remote. We're using a Mortal Kombat 2 PCB here. So let's just see if it turns on, what kind of image we get. If it all works and seems to be okay, then I'll go ahead and just recap it, reflow it, clean it up, show it off, and we'll test it again. But I realize now, of course, I forgot like I always do. Let's connect a alligator clip to the frame and to the screwdriver here so we can test that high voltage leaking from the flyback on that crack. So, okay, here we go. What's going to happen? 1, 2, 3. Comes to life. Nothing's exploded. Uh-oh. 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 Imagine that. What would you even expect on that? Okay. Well, I forgot to mention all of the pots on the neck board were completely maxed out. I don't know if they were trying to move stuff around to see if maybe they can get it to come to life, not knowing what they were doing. I'm not sure, but let's go ahead and check the flyback high voltage leakage while we're doing this. 1, 2, 3. Okay, and let's just see if we have anything here. Nope, it's good. All right, so oh, the flyback was completely maxed out. The brightness pot was, I'm sorry, the screen pot was fully maxed out. But we have this strange phenomenon going on. So, yeah, vertical hold. Let's try and adjust that. Well, that's not what we want. Vertical hold here. Oh! Man, that's glorious! Vertical hold was a little off. I mean, just having it slightly... Right there is dead center. Vertical hold right there is dead center. And I guess if you turn it too far... I guess I must have missed that one. I thought I put them all in the middle. I could have sworn that maybe I missed that one. I don't know. But vertical hold caused that. Okay. Well, look at that. It actually works and looks pretty darn good. Wow. Okay. Don't see any issues. As my oversight on the vertical hold there. Sorry about that. But it looks pretty good. So I think what we'll do is I'll cap it, reflow it, and clean it up, show it off. We'll test it one last time and call it fixed. So, yeah, a bunch of bad solder joints and a bad R104. Imagine that. So let me get that work done and come back and we'll test it one last time. Well, about an hour and a half later, here it is. Completely rebuilt, reflowed, cleaned up, the whole 9 yards. It's not perfect, but I did take some alcohol on a brush and brushed all as much as I could. But all the caps are changed out. Cleaned it up as best I could for what it is. And cleaned up the back as well. Got the reflow on anything and everything that needed it. And of course, we already saw all the rework and touched up places. And got this all clean as well, got rid of all the flux, and it's all looking nice and good. So rework is done on the bottom, rework's done on the top. Neck board, got all the wire harnesses and everything tied up, since we know our flyback is working and good. It's not leaking the high voltage, all that jazz. I got this all tied up, and I got this reflowed and cleaned up, so our chassis is good to go. So I'm gonna get it back on the tube, we'll give it one last test, and make sure everything's still working, and call it done. All right, everything is hooked back up for test number 2. So let's see if anything blows up now or something's different or changed, and see what happens here. So here we go. 1, 2, 3. Okay, comes on. And okay, we don't appear to be any worse for wear. And dang, that looks good, man. Okay. So let's start by going brightness all the way down, contrast all the way, oh, you couldn't see, sorry. I was looking down here and had the camera up. So I just turned the brightness all the way down, contrast all the way down. You know our high voltage isn't leaking, so let's go ahead and turn it up until we get our retrace lines right there, back down till they just go away. Now we'll turn our brightness back up until the background is no longer black. And roughly, come on, focus up here. There we go. Background is not black anymore, so back down till it, yeah, there we go. Back down till it just goes black right there. And contrast as required here. There we go. Dun, dun, dun. And that looks pretty darn good. Focus is immaculate. Convergence is slightly off, but focus is fantastic. Now, of course, the tube has a lot to do with that, but I don't like this iPhone because it likes to get out of focus here. That's better. There we go. Okay, the brightness is we're a little bit too red, so let's turn our cutoff down. That's better. Turn green up slightly, and brightness up a little bit more, actually. There. And look at that, fantastic. We'll shift our H position over just slightly that way, and we're a little bit too blue. Let's turn our blue drive down. Nice. There you have it. I don't know why it's... There we go. Oh, for some reason it only works up to a certain point, but anyway, man, it looks so freaking good. All right, it works. I'm going to turn H position a little bit more off that way. Okay. And now let's make sure our horizontal width can be adjusted. We'll get our width tool out, and we will put this down in our horizontal width coil, and let's make sure that it turns, and it does indeed turn. So I can't get this to focus. There we go. Actually, we need to go in the menu, blink, and go down to monitor patterns, crosshatch. All right, let's adjust this and make sure that we can turn this, and yep, that's going out, that's going in, fantastic. And H position needs to move over slightly, but that's fine. Everything else appears to be good. We got our vertical size, that works. Brightness, contrast, vertical position, that works. Everything else we already tested. We know our screen pot works. Let's adjust our focus, make sure that that works. Oh yeah. And right there is pretty crisp. So we have a functional, rebuilt, working K7000. And you saw the work that went into it. It only had one faulty component. If you don't count the broken pot and the missing pot, we had one faulty component, that original R104 that was open. And everything else was just down to bad solder joints. So, man, nice blues there. And fantastic. How far away can I go? Oh, it's all right. Okay, well, nice. Well, there you have it. So I know you learned something on this one. Make sure you check all those solder joints whenever you reflow and redo these K7000s, because all of them have the same issues. So that being said, I appreciate it. I always say thank you very much for watching. Make sure you like, share, subscribe, comment down below, and I'll link that sanding pen that I talked about in the description. So check that out if you want to get one of those for yourself. And if you do get one, there is a refill cartridge. Oh, sorry. There's a refill cartridge inside here. So when this one goes out, you pop the cap off here, there's a refill cartridge inside of this thing. So you don't need to buy a whole nother one of these when this runs out. So just a heads up. Anyway, so there you go. Thanks again, and stay tuned for more, and we'll see you next time.